Hello everyone. Today we'll be solving problem number 239, sliding window maximum. So you can just go through the question and also you can just go through the examples as well to understand the question pretty well. So I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given an array of integer nums and a window size k. So clearly you can see here we have been given an integers nums and window size k here. A sliding window of size k moves from left to right of the array. Just consider this one just for the sake of example. A sliding window of size k, here they have given size of k 3, this one, right? Size of k 3 here they have mentioned here. You can clearly see here 3 elements we are considering within the window. A sliding window of size k moves from left to right of the array. They have given it moves from left to right of the array, and at each position the maximum value of the numbers in the current window is recorded. Here you can see the maximum is recorded here 3. See here max 3. In the second window here 3 minus 1 minus 3, again 3 is recorded. So at each position, the maximum value of the numbers in the current window is recorded. The task, what is our main task here? Our main task is to return an array of those maximum values for each window position. So we have to we have to return an array of these maximum values for each window position. That's what they have given. Let's consider this example in this case. So they have given here array of integers, right? So and they have given size of k 3 here. So we have to consider 3 elements within the particular window. So output they have mentioned here. How here? So here we can clearly see what we'll do, we'll consider first 3 elements within this window. So that's what they have given here, 1, 3 and minus 1, and we will record the maximum value 3. And second, we will ignore the first element and we will consider next 3 elements, this one. So 3 minus 1 minus 3. Out of this one, maximum is 3 again. 3 is recorded. Will be further we'll be doing the same steps. Next we'll be ignoring 3 and we'll be going with minus 1, minus 3 and 5. This window. Minus 1, minus 3 and 5. 5 is the maximum. We'll be recording the maximum, and for the next 3 steps also we'll be doing the same, and we'll be taking the maximum, right? We'll be recording the maximum. Fourth, fifth and sixth window, the maximum is 5, 6 and 7 respectively, right? So I hope this is clear. The example is completely clear. For the second example, the window of size they have given only 1, right? The size of the k they have mentioned only 1 here. So number integers within the array is only 1 here. Only single element. It consists of only single element within the array, and size also it is of size k. Size of k they have given here 1, right? So the output will be only 1 here. The maximum will be there is only one element present and we'll be recording the max 1. So the output will be 1 here, right? So I hope the question is completely clear. So let's discuss the approach first, then we'll be going with the this one. Edge cases, we'll be discussing all the edge cases, and then we'll be writing the code and we'll be discussing the complexities, right? So let's discuss the approach first. So let's discuss approach step by step. So we'll be making use of the monotonic DQ approach here. So first I'll write, we'll be making use of the monotonic DQ here. First of all, we'll be making use of the DQ or the double-ended queue. What it will do, why we are making use of the double-ended queue or the DQ here? To store the indices of the array. We'll be making use of the DQ to store the indices of the array. Just keep in mind this one. We'll be making use of the DQ or the double-ended queue to store the indices of the array in the way that the largest element of the current window is always at the front. So here largest element will be storing the indices of the array in the way that largest element is always at front. So That is the reason we'll be making use of the DQ. Again, I'm telling, this is important. We'll be making use of the DQ or the double-ended queue, basically to store the indices of the array in the way that the largest element of the current window is always at the front, right? This is thing. So let's discuss the same thing. Let's discuss the further things step by step. First step, what we will do, we will initialize an empty array to store the maximum values of the each window. First step is initialize empty array, empty result array. So I'll just consider here empty result array. Why we are initializing the empty result array here? To store maximum values of each window. To store max value in each window. First step that we need to consider here. And let's move on with the second step, right? So we will be making use of the DQ to store indices. We have discussed this one earlier. So we will be making use of DQ to store indices, right? We'll be making use of the DQ to store indices. This is the second step. So what will be the third step then? So for every element in the array, suppose we have some elements. So here let me consider here up to n. So for every element in the array, we will be removing the indices from the front of the DQ that are out of the current window. First thing here is we will remove indices from front that are out of the current window. So here suppose consider we are having the array of elements, n elements. So we are removing the this one indices from the front of the DQ that are out of the current window. Also we will remove the indices from the back of the DQ that corresponds to the elements that are smaller than current element. So we need to ignore the smallest elements, right? We need to record only the maximum element. So we had discussed the same thing during the example as well. Next, what we will do here, we will remove indices from back of the DQ, right? Back of, I'll just consider DQ, I'll just give here DQ instead of DQ, this thing. I'll just consider DQ, right? So we will be removing the indices from the front of the DQ and we'll be removing the indices from the back of the DQ, right? So next is we have to add the current index to the DQ as well, right? So we have to add current index of the DQ. This is one thing. This is main thing. And finally, if the window has reached the size k means suppose k equals 3, we should consider the 3 elements within the array, right? So if the window, this one, suppose we are considering this window, if the window has reached the size k, or here in this case size 3, then we have to add the element at the front of the DQ. So if window has reached size k, then add element at front of DQ. This is fine. Finally, what we will do, the fourth step is we have to return the array. We will record the maximum element. Just give me a second here. First, I'll just write here, return the result array. Here, let me come to this one too. We will be recording maximum from the each window, right? Here, each window based on the size of the k that they have mentioned. Based on the size of the k, within the particular window, we will be recording the maximum element, maximum number. Here in this case, it will be 3. We will be recording the max value, right? And finally, we will be, in the fourth step, we will be returning the result array. So this will be the approach that we'll be going with. So next, let's discuss all the edge cases one by one and write the program and discuss the complexity. So let's discuss edge cases one by one. So I'll just give here edge cases. So the first edge cases, let's go with the single element window. Let me consider here input nums. Let me give here single element we have to consider here, right? So I'll just give here 1 and k, let me give here 1. So here the output will be 1 here. Why the output will be 1 here? Because we are having only one element and size of the k is also 1. So the output will be 1 here. This is for single element array. Single element, not the array, single element window, right? So this is fine. Let's move on with the next edge case. Let's consider all elements are same. While I say all elements are same, here let me consider the numbers, this one. This is fine. Here all the elements are same, and k, let's consider 2 here. So the output will be 2 and 3 2s right here. First, we will be considering window, this one, 2 and 2. Maximum is recorded here. The maximum will be 2. Next, we will ignore this one. We will be considering this one, 2 and 2. Here again the maximum will be 2 here, right? So first we'll be considering this one and this one. The maximum is recorded. Second, we'll ignore the first one and we'll be considering these two. Third one, we'll be ignoring the second element and we will consider this window, 2 and 2. So this will be again 2 and 2. The maximum will be 2. So that's what we have given here. This is for all elements are same here. All elements are same. So I hope the second edge case is clear. So next, let's move on with the next edge case, the third edge case. Here the third edge case is decreasing the order array. So I'll just give here decreasing order array. Let me consider this one. So within the input, let me consider here, while I say decreasing order array, let me consider the decreasing the elements in the decreasing order, right? So I'll just give here 9876. Let me consider k equals 2. We have already considered, right? Let's give 3 here. So here the output will be, or let me consider this one directly. Just give me a second here. Output will be 9 and 8 here, right? So you can clearly see here k we have considered k as 3, right? The first window here will be 987, right? Out of this one, maximum is 9. So next we will ignore this one and we'll move to the next window, nothing but 876. Out of this one, the maximum is 8. So we'll be considering this one itself, right? The output will be 9 and 8. I hope this one, third edge case is completely clear. So next, let's move on with the last edge case or the fourth edge case. This is for the large window size. So while I say large window size here, let me consider input here. Nums, let me consider some numbers 1 2 3 4 5. So k, let me consider here 5. So large window size, this is the window size, right? We are considering the window size as 5. This is the large window size, obviously, right? So let's here first what we will do, we have to consider for the 5 elements. The first window consists of 1 2 3 4 5. Out of this, the maximum number is 5. So the output that we need to get here is 5 as well. So the output will be 5 here. within the array. Let's mention the output as 5 here. This is fine. So we have discussed all the edge cases here. First one was for the single element window. We saw the second one was for this one. All elements are same within the array. The output that we got here is this one. Third one was for decreasing order array. We saw the output that we got here is this one 9, 8. The fourth one was for large window size. The output that we got here is 5, right? So I hope all the edge cases are clear. Let's start writing the code, and I'll explain the code while writing the code itself. So let's start writing the code here. First, as we had discussed in the approach, let's make use of the result array to store the max values of the window. Also, let's initialize the monotonic dequeue to store the indices. So I'll just give here max values. Also, let me consider, sorry, let me give here dequeue. Initialize this to the empty array. So just give me a second here. Let's continue with the iteration part, right? So I'll just come here for let a equals 0, length of the nums. This one is fine. Then we had discussed this one. We have to remove the indices from the dequeue that are out of the current window. Also, we need to remove the indices from the back of the dequeue whose value are less than the iterated value of the nums. We have discussed this one, right? First one is we have to remove the indices from the dequeue that are out of the current window. This is simple if condition. If dequeue, if sorry, what is happening here? If length of the dequeue and dequeue of 0 less than or equal to I minus k, what we'll do? Let's make use of shift. This is fine. Second one was we have to remove the indices from the back of the dequeue as well, whose value are less than iterated value of the nums. Let me consider the simple while loop for this. Let me consider same thing. Here, let me consider length of the dequeue. Let me copy this one. Let me paste this one here. And we'll be considering, we have to remove the indices from the back of the dequeue, right? Let me consider here nums of this one is fine. Dequeue or at, let me give here minus 1. Whose value are less than, we have to remove the indices from the back of the dequeue whose value are less than iterated value of the nums, right? So less than iterated value of the nums. This is fine. So somewhere I missed something here. So this array here, I have to close this one. Let me delete this one array here. So this is fine. We have to remove that one, right? For removing, I'll just make use of pop here. So this is fine. Then after doing this one, what we'll do, let's add the current index to the dequeue. So I'll just give here, I'll just make use of the push. We are just pushing the current index, nothing but the iterated, current index to the dequeue. After adding the current index to the dequeue, let's add the maximum value of the window to the result. We have to add the maximum value of the window to the result, right? That's what we have to find out here, the maximum value within the each window. So I'll just write a simple if condition again. If I greater than or equal to k minus 1, then what we will do? We have to add the maximum value. So max values, I'll just make use of the push to add the value. Here, nums of dequeue within the array, let me give 0 here. I hope this is clear. Finally, we have to return the array of the maximum numbers within the each window. So I'll just return here max values. Max values is what I have considered here, right? This one. So yeah, max values. So let me format this one once. So let me hit the run. So you can clearly see here the sample test cases are getting passed. So let me hit the submit button. So you can clearly see here the code works absolutely correct. All the test cases are getting passed, right? So the code works absolutely fine. So let's discuss the time complexity and the space complexity very quickly. So here the overall time complexity would be big O of n. So why the time complexity would be big O of n here? Because we are adding the each element and removing the each element from the DQ at most once. Again, I'm telling, we are adding and removing the element from the DQ at most once, right? So push and pop here, whatever we are making use of. We are adding and removing removing the element from the DQ at most once. So the time complexity here, overall time complexity would be big O of n. So what will be the space complexity then? The space complexity will be big O of k. Why the space complexity here is big O of k, not the big O of 1 here? Because we are storing uh, in the DQ at most k indices at any time, right? So that is the reason the overall space complexity here is big O of k. I hope this is completely clear. I hope the solution is completely clear. So for now, this is it. Thanks for watching, guys.